In this video, CALCut calculates how a 20 kilowatt fiber laser could cut a 10 mm thick tungsten wall of a fusion reactor. The video displays the complete calculation course of CALCut. First of all, starting with the parameter setup. All the parameters are selected, like here the pressure, the wavelengths of the laser, the beam quality, we select a fiber laser with 20 kilowatt beam power, and we try a beam diameter of 40 millimeters at the focusing optics, using focusing optics with a focusing length of 350 millimeter. Of course, we have to adjust the material thickness to 10 millimeter. And what we see is the resulting focus caustic with its isophotes. But the beam parameters are not yet as we wanted. So we adjust the raw beam diameter to get a more slender beam. Trying a smaller raw beam diameter, still not what we want. So we adjust it to a smaller raw beam diameter to get a focus caustic which should be appropriate for this material thickness. Now we select the procedure with which CALCut calculates. So we use variable speed and multi-fraction calculations. We see how the calculation develops. We see on the left side the cutting front, and on the right side a cross-section of the developing cutting kerf. CALCut does these calculations from cutting segment from the top to the bottom, always trying to fulfill the balance of power and mass. So that we get the solution for a stationary cut. Stationary means steady state solution where all the power, the mass balance and the force balance are fulfilled, step by step, from the top to the bottom. This needs some time because the consideration of multiple reflections is quite expensive. Now we nearly finished the calculation. We need some more time for finalizing the development of the cutting front and the kerf. And we see with the parameters we selected, we really were able to do the cut through 10 millimeter tungsten with the parameters of a 20 kilowatt fiber laser. We see the absorption, the process temperature, of course the selected feed rate, the average kerf width, many other performance indicators of the cut on the left side for the insiders. And we can also look at the distribution function of the cutting front. Here we have the complete view again of the cutting front and the kerf.